Subject code 18CS2017 Operating Systems Lab. Experiment number 4 CPU scheduling algorithms. So the first one here we see is first come first serve algorithm. So we'll start from the function call below. This is the function call, and now we have a parameter that is burst times, which is nothing but a list of all the burst times for each process. So burst time is nothing but the time for which a process resides in the CPU, right? So we have a list of all those burst times for each process, and now we are passing that one to the function above. So this is the function. Fine. Now we are printing a heading called process burst time, waiting time, and also turnaround time, which is nothing but those are the columns which we will be filling using the code. Fine. So we'll be calculating waiting time and turnaround time. Since burst time is already given by the user, and process we can name it as P0, P1, P2, right? And now we'll be calculating waiting time and turnaround time. So I have set them initially to 0 and I is equal to 0. That is nothing but the while loop pointer. Now we'll talk about these two lists, empty lists later. Now inside the while loop we have a condition called I less than length of burst time. That is nothing but length of the burst time is nothing but the number of processes, right? So for each process this iteration should run. Now inside the loop, this loop, we are incrementing turnaround time by the corresponding burst time. So, fine. In first pass, we'll be having the burst time of the first process into the turnaround time. In the second iteration, we'll be having the burst times of the sum of the burst times of the first two processes. So that's how we calculate the turnaround time, right? So turnaround time is nothing but the waiting time for a process added to the burst time for the same process. That is nothing. That is about the turnaround time, right? Now after that we are doing a print statement called we are printing the process name, that is P and the corresponding number, process number, and we are printing the burst time, str of burst time, and we are printing the waiting time along with the turnaround time at last. So waiting time initially is 0, so 0 will be printed for the first process. Since the first process doesn't have to wait, so the waiting time though of the first process will be 0. But for the second here we can see in the 13th line, for the second process the waiting time should be the burst time of the first process, right? So burst time of the first process in this case is 24. So the second process has to wait for 24 time units. So we are incrementing wait time by the corresponding burst time value in this list. Fine. After that we are incrementing this I value such that this condition will be met and this while loop will be terminated. This is how we'll calculate the waiting time and turnaround time. And each time when you print this waiting time and turnaround time, we are adding those values to two empty lists. This is for the waiting list, and this is waiting times, and this is for the turnaround time. So after all the iterations, we are returning a tuple object, that is empty1 and empty2, that is waiting times list and turnaround times list. So this function in this variable will be having this tuple object, right? So after that we are calculating the average waiting time, that is empty1. This will have the tuple, right? So under the index 0 we'll be having the waiting times, right? So we're calculating the sum of all the waiting times divided by the number of waiting times, that is number of processes, that is taken by the length. Fine. After that we are printing the average turnaround time by just giving the index 1 here. So that means that at the index 1 we'll be having the turnaround time list, right? So we are adding all those values and dividing by the number of processes and printing this turnaround time. So now quickly we'll run this and check for the output. Enter the number of processes. Let's give it as 5, for example, and the burst time for the process 1 is, let us assume it as 5, second one is 3, third one is 1, 2 and 3, and that's it. Now we can see the burst time have been listed here, and the waiting time and turnaround time. The waiting time for the first process is 0, waiting time of the second process is the burst time of the first process, that is 5. So waiting time for the process 3 is the sum of the burst time for the previous processes, that is process 1 and process 2, that is 8. So in this way we'll be calculating this waiting time and turnaround time using the first come first serve algorithm. Now the second algorithm here is the shortest job first algorithm. So in this algorithm the highest priority is given to the shortest job, so that will be given the CPU first. Fine. Here is the function. Now we'll start from the function call below. So here is the function call. So there are two attributes we are passing to this function call, that is sorted of burst times and burst times. So we are doing a sorting operation here, so such that the shortest burst time, the processes that those having the shortest burst times will be in the first position of the list, and this burst times is a normal burst time, that is without sorting, unsorted normal list. Fine. Now here we are receiving those parameters, and we are printing this heading: process, burst time, waiting time, and turnaround time. So in this algorithm we'll be calculating waiting time as well as the turnaround time, right? So that's it. Now this is nothing but the while loop pointer. Now we're coming to the waiting time and turnaround time. Since we need to calculate these two, we'll set it initially both these variables to 0. Fine. Now inside the while loop we have a condition called I less than len of burst time, similar to the first algorithm. This is nothing but the we'll be having the number of passes that is equal to the number of processes. Fine. So that's why I have given length of burst time. Now we are incrementing turnaround time by the corresponding value in the burst time list, and after that I'm printing the value, that is x dot index of burst times of I plus 1. So in the first come first serve algorithm, we just had to print the sequential order, that is p1, p2, p3, p4, and p5. But in this case it's not like that. We need to print the process number which has the shortest burst time, right? So that's why I'm using this index function, which gives the index of a particular object in a list, index of the particular burst time of I in the unsorted list. Fine. This x is nothing but the unsorted list here. In the unsorted list, what is the index of the current burst time? For example, if you have some values in the burst times list, and if you sort it, the positions will change, right? So we need a reference for the previous list also. So that's why I've taken x, and after that I'm printing the burst time. So whatever the burst time, that will be printed beside this one, and after that I'm printing the waiting time. Waiting time is initially set to 0, that will be 0 itself, and turnaround time which we have incremented just now by 5. Sorry, the first item in the burst time. After that I'm giving x dot index of burst time 5 is equals to -1, such that for example, if there are any duplicates in the list burst times list, so index function will give the index of the first item itself. So for if you have 3 and 3, so index will be given, that function returns index as 0. It ignores the second occurrence, right? So we are replacing the value with some impossible value, that is -1. -1 cannot be included in burst times, right? So we are replacing the value with -1, such that if the duplicate item is encountered in any iterations, so, then index function will return the correct position of that item. That is the main reason behind this. Now I'm appending this waiting time and turnaround time to this empty list given here just to calculate the average of the waiting and turnaround times. Fine. Now I'm updating the waiting time, incrementing this by the burst time of the corresponding burst time. So in the first iteration it prints waiting time as 0, and in the second iteration it prints the waiting time as the burst time of the first item. So that is what happening here. Now I'm incrementing the while loop pointer. After all the iterations, now we are returning the to list which contains waiting times in the first list and the turnaround times in the second list. So we are receiving that one here, and we are calculating the average by using sum function and by dividing by the length function. So in the index 0 we'll be having the waiting times list, and in the index at the index 1 we'll be having the turnaround times list. Now let's quickly run this and check for the output. Number of processes, let us assume it as 4. Burst time for process 7, 9, 3, 8, for example. Now we can see the shortest burst time is here, process 3, that is taken first, and the burst time of that particular process is 3, and the burst time of the next shortest process, that is 8, right? So the process 4 is selected. Now such a way we'll be calculating all the burst times and waiting times, and also we'll be calculating the average times using this MT1 and MT2 list. Now the next algorithm here is round robin's algorithm. So in this algorithm, what happens is each process gets an equal share of the time, which you call as a time quantum value. Once the time quantum value is finished, what happens is the information of the current process will be saved into the process control block, and the next process will be the CPU will be given to the next process for the same time quantum value. So this process is also called as context switching, and this happens in the round robin algorithm. Right now we start from the function call below. We have the function call here. We are passing the two parameters, that is burst times and time quantum value. Burst times is nothing but the burst times of all the processes here, and the time quantum value is the amount of time restricted for each process to be executed. Fine. We are passing those two parameters to this function. Now here we have this function. Now we are taking 3 copies of the burst time. So I'm using this slicing method just to ensure that if you change any values in this copy list, the original value doesn't get affected. So if you don't use this, if you just give it like this, what happens is the original value, it just becomes a reference to this original object, right? If you change any value in this, the original value, that is burst times list, will be affected. Fine. I've taken the 3 copies of this burst times list, and initially what I'm doing is I'm using this while loop. What I'm doing is I'm calculating the order of the processes, right? By simply what do you call, by simply subtracting the each burst time with the time quantum value, and the value that is left over, I'm storing that one is in k. And in that way, if k is less than 1, that means that if the process has been finished, that means that if the burst time burst time is 1 and the time quantum value is 2, in that case it will be less than 1. The process will be finished in the first allocation, right? So that's why I'm giving it is none. I'm updating the value there and using none, this with this none. Fine. Or else I'm keeping the remainder value at that particular location. So that way I'm checking condition also here, if w is equals to length of copy 2 minus 1. So in that case, if w that is the index that is used to access the list using the index, right? W is index here. So if that one is equals to the length of copy 2 minus 1, that is if it has been if it has traversed across the list, what we are doing, we are resetting the value that is w to 0. That means that uh, the list will be given again to this again consider for this while loop, and the same process continues until here we can see we'll be having a break condition here, that is copy2 dot count of none is not equals to length of copy2. Once the count of none in copy2, that means the none will be replaced with the original burst times in the value only if all the processes have been finished. If all the processes have been finished, that means that k is less than 1, right? So then we'll be having none in all the positions in this copy2 list. So if that count is none is equals to length of copy, that means that if all the objects in the list have got none, then this process finishes. That's how we calculate the order of the processes using this while loop. Now under this I have another while loop. Using this while loop, what I'm doing is I'm calculating the waiting time. Fine. It just calculates the sequential waiting times. In the record we have seen some time slots, right? So those time slots values will be calculated using this waiting time. So the same process, if here we can see we are subtracting the burst time value with the given time quantum value. If that one is greater than or equals to 1, then we are appending that we are appending the s value. S value is initially set to 0, which is meant to calculate the waiting time actually. So we are appending this s value. Before that, we are incrementing the s value by the time quantum value, which indicates that it is the process is not yet finished. It is the difference is still greater than or equals to 1. That's why we are appending that s to the waiting times list, and we are replacing the particular value in the burst time with the difference, that is k. After that, this is I'm incrementing this j. Just a minute. And after that, I'm checking another condition, that is that k less than 1. That means the process has been finished. If the process has been finished, we're incrementing the s by the burst time itself. So the time quantum, full time quantum need not to be added to this burst s, right? So if the process has been finished, whatever the burst time it has, it will be updated with s. Now we are appending that one to the waiting times list. Now we're incrementing j, and after that we are setting the current position in the burst time as none, indicating that the process has been finished. Now just a minute, we are incrementing this I. So once I is equals to length of the copy 3, that means once one iteration is passed, I is again reset to 0 and j to 1. Fine. After that, we have a breaking condition here, that is elif burst times dot count of none is equals to length of copy. The similar one, if the count of none in the burst time is equals to the number of processes, length of copy 3 can also be taken as number of processes, right? So if that even is true, then we'll be breaking this while loop. The while loop will be terminated. Now after that, I'm using this zip function to map each object of the processes to the waiting time. So what it does is it creates a tuple object with the two values together. So the first process will be having the waiting time as well. So in that way, I am converting that to list and storing that one as TOT variable. And yeah, using this while loop, I'm actually calculating the waiting time for each process. And these are the variables I have said before. This is a sequence empty list, and I have a condition here while q less than length of copy3 plus 1. So we'll see it later, the condition. And inside this, we can see we'll start from this for loop first, and we'll see about the remaining conditions above. So in this range, there is the length of the seq. Then I have set if max of seq of I is equals to 0. That means that seq of I is nothing but a tuple object which we have zipped right above. Using this zip function, we have we converted that one into list and stored that in TOT variable. Now using this while loop, I'm calculating the positions of the processes, out of the processes which are stored in TOT. Like initially the position starts from 1, right? So I have set q is equals to 1. So in the 0th location, what we have is the process number in this TOT file. Sorry, TOT list, and if that one is equals to q, then stored append of I. So what we are doing basically using this while loop is we're just creating another list, that is seq, and we are storing some information, that is the indices of the processes. That is, if the first process is at the index 1 and index 5, then 1 comma 5 will be appended into this list. Likewise, and if the second process is at some index 2 and 3, so 2 comma 3 will be given into this list. So that's what we are doing using this while loop. And after that, here using this for loop, I'm actually calculating the waiting times between the consecutive two processes, right? I'm using this for loop in the range of len of seq. That means that the number of processes, we can assume it like that. So I'm taking these two variables, total equals to 0, j is equals to 0, and if maximum of seq of I is equals to 0, that means that it is in seq will be having the starting index and the ending index, right? So the last index. So if the last index is obviously it will be the maximum. If the maximum of the seq of I is equals to 0, that means that if it is nowhere repeated in the list, so what we're doing is we are inserting we are taking a list called waiting time up to that variable, that is I. We are using the slicing function here, and we are inserting 0 to this inserting 0 to this a list at 0th index. And after that we are iterating in the reverse order in this range, length of a minus 1 up to 0, and we are calculating the total waiting time, like the waiting time of the particular tuple value in the list minus the waiting time of the item towards its left side, that is k minus 1, right? And after that I'm appending this total to this SCIN empty list, right? After that I'm deleting that particular record from the TOT list. After that I'm using a while loop, which is this is an exceptional condition. If maximum of seq of I is equals to 0, then this condition will be true, otherwise we'll be executing this while loop as default. Now while j less than maximum of seq of I, for example, if the value is spread until 5 in x5, so this will be 5, right? So until 5 we'll be calculating, and so j starts from 0 here. So if maximum of seq of I is 5, then until 5 we'll be calculating the corresponding consecutive waiting times, that is j plus 1 of I minus j of 1, j plus 1 of 1 minus dot of j of 1. So in that way we'll be calculating the total waiting time, and we are incrementing the j as well. And if it is equals to I plus 1, if we have encountered the same process number, then what we are doing, we are just incrementing the j plus 1, so that we are ignoring that one. We will not be calculating including that one, and we'll just ignoring that one and incrementing the j pointer. So if j is equals to maximum of seq of I minus 1, if all the iterations have been finished, then we are checking. If I is greater than 0, then if I is still greater than 0, then what we are doing, we are incrementing total plus is equals to waiting times of I minus 1. So that and after that we are appending this total value into this SCN. So what this means is we are calculating the waiting time for each process in each iteration, right? After that, we are breaking this loop. So in this way, we'll be calculating the waiting times of for each process. Now we are printing the heading, that is process burst time and waiting time, and using this for loop, I'm actually printing the values, that is the process burst time. The process and burst time are initially given by the user, and we need to calculate just waiting time and turnaround time. So to do that, uh, I'm uh, I'm just printing the values from the waiting time and burst time for the turnaround time. Now I'm just returning some values, that is average waiting time and turnaround time. The average waiting time happens to be the sum of the SAN sum of all the items in the SAN list and the length of that list. Now the uh, this average of turnaround time will be the we just have to make a list of both these added values, right? So I'm using a map function here, which takes the values from the uh, two lists, that is copy1 and SAN. Copy1 is nothing but for waiting times, right? So it just have the it has the burst times, and SAN has the waiting times, and it takes two inputs from this two lists and gives to the sum function, which will be stored into this list, and we are dividing by the length of that list, and in that way we'll be calculating the turnaround time. After that, we're returning this double value to this here LIS, and we'll be printing average waiting time and average turnaround time. So we'll quickly we just run this and check for the output. The number of processes, let that be 5. Burst time for process 1 is 5. Let us take it as 5 3 1 2 3, and the time quantum value, let it be 2. Now we can see the burst time, waiting time and turnaround time, and average waiting time is 7.4, and the average turnaround time is 10.2. So next algorithm here is the priority scheduling algorithm. So where we schedule the processes based on their priorities. So we'll be taking the priorities of the each process as an input from the user. So we'll be scheduling them based on this, based on the priority, that is based on the highest priority. Now we start from the function call here. So we have function here priority, and we have a function call here, that is just a minute. So here we have a function call, that is priority. We are passing two parameters for that one. First one is the burst times, and second one is the priorities. So the burst times happen to be the burst time of each process. The priorities happen to be the priorities associated with those burst times. Fine. Now we look into the function here. Now I'm printing a heading called process burst time and waiting time, and also we have a turnaround time. So process and burst times both will be given by the user, and what we need to focus on is waiting time and turnaround time. So since we need to calculate both this waiting time and turnaround time, initially we set those variables to 0, and this I is nothing but the while loop pointer here. So we'll see about these two lists later. Now coming to the condition in the while loop, that is I less than length of burst time. Length of burst time is nothing but the number of processes, right? So this loop runs for all the processes, for each process. Now we are finding the minimum of the priority. So if the priority of a particular process is 1, so I have taken like it has the highest priority, right? So I'm calculating the minimum of the current the list, that is priorities. Now I'm calculating the turnaround time by I'm just incrementing this turnaround time by the burst time, and I'm using the index function. This burst time of priorities dot index of k. So k is the minimum of these priorities, right? So I'm just getting the index of that minimum value from the priorities list, and I'm giving that one as the index to this burst time, such that we'll be able to get the actual burst time of the highest priority process. So I'm incrementing the turnaround time by that. So initially it will be set, it was set to 0. Now it will have the burst time of the first the highest priority process. Now I'm printing the I'm using a print statement to actually print the priorities the burst time, waiting time and turnaround time. So I'm just taking p, and this is str function which I'm using to give the process a number. So the process number should be the index of the process in the priorities list, right? So I'm just using the index function to get the index of that one, and after that I'm giving a space, and after that I'm printing the burst time, that is str of burst time of priorities dot index of k. So I'm just taking the index of that minimum priority, and I'm giving that one to the burst time index variable. So what it will do is it will actually take the burst time value of that particular priority. After that, I'm printing the waiting time. So we can see str of waiting time, which is set to, initially it is set to 0. After that, I'm printing a turnaround time. In turnaround time, which was actually incremented just now, that will be printed here. And after that, I'm appending the waiting time and turnaround time to these two empty lists, which is nothing but just we are calculating the just to calculate this average time for the both waiting time and turnaround time. And after that, I'm incrementing this waiting time by the the process that has been selected for that, but that means the process with highest priority. We incrementing the waiting time by the priority stored index of k, and I'm giving that one as an index variable for this burst time. That means that the burst time of that particular process will be selected, incremented to this waiting time, which is a variable that is already set to 0. I'm incrementing this while loop condition, that is a pointer I, and such that this condition will be false at least once. And after that, in this priorities list, what I'm doing is I'm just at that particular index, I mean the highest priority index, I'm just giving some impossible value, that is maximum priorities plus 1. So maximum priorities plus 1 will be the value which is not present in the particular list, right? So I'm just replacing that value with some other value, so, in order to avoid the duplicate values in the list. Now after that, I'm returning these two values, that is empty1 and empty2. Both these lists will be received here, that is alias, and I'm just calculating the sum and length of that list and converting that to str and appending with this, sorry, concatenating with this string, rest of the thing. And now let us run this code. And we'll check for the output. Now enter the number of processes. Let us give the process number as 5. Burst time for the process 1, 5, 8, 2, 3, 6, and we need to enter the priorities as well. So under the 5 priorities, let us assign priority 3, 2, 5. 5 means it has the least priority. Now for process 4, let us give it as the first priority, and process 5, let us give it as 4. Now we can see the process that has the first priority, that is P4, has been selected first. And now the next priority is given to the process 2 that has been selected next. So in such way all the processes will be scheduled based on the priorities. I hope all the outputs are correct, and thanks for watching.